Okay, in 4.1, we just introduced what a set and subset are and a little bit of notation. In 4.2, we're going to do some operations on sets. And there are three operations that we can do. They are union, intersection, and complement. So I want to give you a little example, like real life example to kind of ground you in these concepts. My partner and I have both traveled to some popular travel destinations and countries. And if I wanted to look at combine all of the places that we've both traveled, whether we were together or not, then I'd be finding the union of our travel destinations. So that would just be listing all of the places I have been and all of the places my partner has been. Then the intersection would just be the places that we've been together. So it would be probably a smaller set because we haven't been everywhere together. We haven't been together our whole lives, just for the past 12 years, 14 years. Yeah, 14 years. So there are some places that we went before we met that wouldn't be included in that intersection. So the intersection would just be places that we've been to together. And then the complement, if we wanted to look at all the places that we hadn't been, maybe we narrow it down to like popular travel destinations. So the complement of where we have been would be all the places we haven't been. So hopefully that just kind of gives you the idea of the concepts. And then, of course, we have new symbols to learn. So union is represented with this U that I'm highlighting here. Intersection is an upside down U. And then complement has different notation. I use the C one. So it's like a exponent of C is for complement. But you may see the little like exponent of a looks like a part of a quote. I forget what that symbol is. Apostrophe? Yeah, apostrophe. And then the little squiggle A is the other notation. I haven't really seen that much, but just in case you run into it. But the main one we're going to use is the exponent of C. And it's read as a complement when you see it that way. So we have some sets, A, B, and C. A is red, green, and blue. That's what's in that set. B contains red, yellow, and orange. C contains red, orange, yellow, green, blue, and purple. So we're going to write what the, oh gosh, my lettering got messed up. It should be A. It doesn't matter, but I'll probably get that fixed. A is find A union B. So that means I'm taking together everything that A has and everything that B has, and anything that they have in common we don't have to write twice. So for example, or the way I think the more systematic way that I like to do this is I'll just list everything that A has first. So red, green, blue. And then is there anything B has that I haven't listed already? Yes, yellow and orange. Okay, A intersect B, so this is like only counting what they both have. So the only color that they both have in common is red, so the intersection of A and B is just red. A union C, well, if you look, everything that's in A is already in C, so the union is just C itself. So I'll just write everything that's in C. Notice that I'm not writing, if they have a color in common, I'm not writing it twice. There's no need to do that. Oops, that should be blue. And purple. Okay, B union C. Again, everything that is in B is already in C. So it's just going to be the same red, orange, yellow, green, blue, and purple. And then the intersection of A and C, well, that's just A because everything that's in A is in C, so I'm just going to list red, green, and blue. Because all of those colors are also in C. I hope that makes sense. All right, the universal set is a set that contains all the elements we're interested in. So for example, with the colors that we just did, our universal set could be all of the colors, or it could just be all of the primary and secondary colors. You can define it however you want. But it's like the bigger picture, like what are we considering here? And then a complement is relative to the universal set. So you can't find a complement without knowing what the universal set is. So it contains all the elements in the universal set that are not in the set itself. So we'll do some examples. We have the universal set is just the numbers in this example anyway. It's just 1 through 9 integers. A is all the odd numbers in that set, and B are all the even numbers from that set. To be a universal set, all the sets A and B would have to contain elements that are also in the universal set, which they do. So first we'll do a union B. So that would just be all of the odd numbers and all of the even. So we just get back the universal set. It's not always that easy, but in this case, I'm just combining odd and even. So I get back the set. Now A intersect B, there's nothing that they have in common. So you can write the curly brackets with nothing in it or the no smoking sign, but don't put the no smoking sign in here. That's saying that the empty set is part of the set. Doesn't really make sense. And then it's not empty anymore. So A complement, since A is all the odd numbers, the complement of that with the universal set would just be all the even numbers. And then if you union that with B, well, B is already all the even numbers, so you just get all the even numbers again. So it's a simple concept, but it does take a little bit of practice to get used to that.